welcome to this new episode of CCIR Student Spotlight. With us today is Rachel Liu, a 12th grader currently at the Carey Baptist Grammar School in Melbourne, Australia. During her time at CCIR, Rachel took part in the one-on-one mentorship program and worked with Dr. Landry from UCLA on a project that ultimately centered around RNA therapeutics. So just to begin, Rachel, thank you so much for taking your time and welcome.
Thanks, it's great to be here.
So Rachel, why don't we begin by, why don't you share a little bit about yourself? To begin with, just say a little bit about who you are, where you come from, and maybe what first led you to look into this particular area of study for the one-on-one mentorship.
So, as you mentioned, I'm in 12th grade at a high school in Melbourne, Australia, and I've always been broadly passionate about all sciences, but I'm particularly interested in biology, which led me to take a year 12 biology course in grade 11. So I was ahead of my year, and after completing that course, I still had an interest and a passion in biology, and I really wanted to find ways to extend myself in that area. And so I looked for different opportunities, and I came across CCIR, and I thought it would be a really good way to kind of challenge myself and also explore, I guess, deeper niches that and interests that I had in biology.
Mm-hmm. And tell me about those deeper niches. Did you know that you were going to do something in sort of the broad space of genetics to begin with, or were your interests sort of more diffuse at the early stages?
I guess coming into the program, when I did my year 12 biology course, I thought, wow, I know so much about biology and everything. And we learned about CRISPR-Cas9, which is a gene editing technology that's kind of emerging and not being used yet on humans, but it's been used on various plants and other things. And so I guess in my interview, I mentioned my interest in this gene editing technology. But I guess now that I've done the course, that's kind of like a surface level, and I had no idea how deep the field of gene editing tools and biotechnology actually was in the real world. And I'm really glad I did this course because it opened your eyes into something I didn't even know existed, and it was a really good experience to be able to kind of investigate and dive deeper into like what I was really interested in.
Mm-hmm. And tell me a little bit about this process of coming to realize that you actually were only sort of scratching the surface of this field of study. So at what point was it sort of during your intro meeting with Dr. Landry that you began realizing sort of how complicated this might be, or at what point did it really begin sort of dawning on you that that the field was as expansive as it is?
Yeah, so Dr. Landry has a lab at UC Berkeley that utilizes nanotechnologies for engineering purposes. And I guess during our lectures, she would dive deep into the different types of nanomaterials and nanotechnologies outside of just CRISPR-Cas9, and kind of learning that the fundamentals you learn at school kind of really do get applied to real life science and research, but in ways you wouldn't expect it. And learning about mRNA vaccines, which were actually used in the COVID-19 vaccine, and learning about different DNA delivery vectors and lipid nanoparticles, and learning about this whole world I didn't even know existed. And it was really great to see how the basics you learn at school, they get applied.
So tell me a little bit about how then you eventually worked your way towards something more concrete as a research project, because this is a common problem that a lot of students face, and they're very much daunted by the idea of having to do something like a research project, given that you're essentially working in a field that you, as you said, didn't even know existed. So tell me a little bit about this process. How did Dr. Landry work with you to sort of eventually narrow down your focus and realize what exactly it was that you were interested in?
So deciding on my topic was actually really challenging. I think it took 2 weeks, and Dr. Landry kind of encouraged me to kind of see what was out there. And I had about 2 pages worth of different ideas on what I could write my research review paper on. and it was like a long list of different topics that I would be really interested in. And I could write probably a 100-word research paper to try to cover all these topics, but I'd probably be here until I was 50. But yeah, so drilling down into like a specific area was challenging, but as cancer, I found that when I was doing my research on where the future of the nanotechnologies lie is kind of used for cancer treatments. And so since cancer is such a disastrous disease that kind of impacts a lot of people personally, I think it touches probably every single person in the world. You probably know someone who has cancer or you have cancer. And I think since it's such an emerging field, and people are starting to use these nanotechnologies to treat cancer, I thought it would be a very good paper to see the ongoing innovations and try to provide some hope for the future. And yeah.
Mhm. So I mentioned earlier that your project was on RNA therapeutics. If you don't mind, can you give sort of a quick elevator pitch of what sort of your paper was generally about?
So my paper's been titled RNA-based Therapeutics, a future in Cancer Immunotherapy, and it investigates and talks about the three latest applications and progress in RNA-based technologies, microRNA, short interfering RNA, and mRNA-based vaccines, which are currently the most recent technology being developed and used as COVID-19 vaccines. And I talk about the different applications in the three different technologies and the future that they hold for cancer and how they provide a really vast potential and probably a very applicable and attractive technology to be used to treat cancer in the future.
Could you say a little bit more about what makes this particular technology sort of so potentially revolutionary?
So the common theme about the three technologies is they utilize RNA ribonucleic acids, which are naturally occurring in our body and are part of the central dogma and expressing of genes. And so they're kind of like natural in our body. So why they're so emerging and I guess so attractive for future applications is because I guess they have potential to have less side effects compared to traditional cancer therapies, such as like chemo or radio. These have really bad side effects. And so the hope for RNA technologies is since they kind of utilize the natural processes in our bodies, they'll have less virulent side effects on our body and hopefully have better outcomes in treating and trying to reduce cancer in human bodies.
And just out of curiosity, what, as you looked into this, what is sort of the current state of the art research? How far are we from, let's say, clinical applications by your own estimates?
Well, mRNA, which are microRNA technologies, they've been around for quite a while. I mean, the first discoveries happened in the 18th or 19th century. And so they've been around for quite a while, and people, I guess the biggest barrier to all three of the technologies is the safe delivery of these molecules into the human body. And we're getting to a point with lipid nanoparticles and other chemical modifications to try to get it safely and effectively into the body and taken up by our systems. But I think there would be quite a bit more to go in terms of clinical trials and testing and safety for the intracellular delivery of these particles.
Mm-hmm. Yeah, so like a good scientist, you're resisting from making any sort of concrete predictions. That's okay. So I want to take a step back now and ask you a little bit more about your sort of relationship working with Dr. Laundrie and how that dimension of this whole program might have impacted you. So a big part of this program is definitely getting you guys to explore a field and acquire more knowledge, acquire certain skills. But beyond that, especially for the one-on-one mentorship, the mentoring aspect of the program is really, really central. So could you tell us a little bit more about what it was like working with, a nanotechnology scientist and biologist at UC Berkeley?
I think I got incredibly lucky with getting Dr. Landry as my mentor. And uh, first off, she was super inspiring to me, like doing some background research about her and learning a bit about her background. She studied chemistry and physics in university, but now uses that knowledge for biology and bioengineering purposes. And as someone who kind of saw the three subjects in school as kind of concrete, separate entities, like biology doesn't merge with chemistry and it doesn't merge with physics. It's more of a, like, there are three subjects and they're distinct. And he kind of slowly opened my eyes to being able to see that for innovation and for learning and innovation and research to happen, you kind of have to merge these fundamental concepts and be able to work with them as a whole in order to kind of make advancements in fields. And she's been really encouraging about kind of just pursuing what I'm super interested in, just investigating and learning about anything that I'm interested in and not being afraid to just try and see where things would take me.
Mm-hmm. Yeah, that's fantastic to hear. And I want to pursue that thought a little bit further. Oftentimes we hear students taking these sorts of programs, and you've already mentioned a little bit about this, how it's sort of shaped your understanding of the field and expanded your horizons there. Has it at all sort of shifted also your understanding of, let's say, your practical relationship with the field, as in like what you want to do in the future and so on and so forth?
In terms of what I want to do in the future, I guess it's always been out in the open. I'm not exactly concretely fixed on a path that I want to do. And I know I want to do something in the field of science, but I'm not exactly sure what I want to do, which is something I've been in discussion with Dr. Landry, and she's been super supportive and said I can always email her if I've got questions about future university courses or future jobs and things like that. And I think I do volunteering for my local council for local government, and we kind of provide a young person's perspective on things that should change and innovations that need to happen around our local area. And a lot of people are super surprised that I do this because it isn't science related at all. But I think she opened up that and taught me that kind of science is all about working with people, and innovation isn't going to happen in the field of medicine without learning from people all around the world and more knowledgeable people. And, you know, everyone has something that they can share and help and contribute. And it's all about being able to collaborate with these people in order to, you know, make innovations and advancements in treatments and to help people all around the world.
Mm-hmm. And so this last point I'm especially interested in. So when you're talking about how science requires cooperation with and communication with large numbers of people, I imagine here you're actually extending beyond sort of even just the scientific community or so on. So I'm just curious, in sort of your understanding, how does, let's say, working with ordinary people without scientific backgrounds, how does that process also inform the enterprise of science? Because I definitely agree that I think it does, but I'm curious to hear your perspective.
I think that a big part of science and I guess medical treatments is making sure that ordinary people know what's going on and understand their treatments and understand that what what they're getting done to them. And I think a big part of that is also, in order to improve treatments, it's also talking to the ordinary people that are getting directly impacted by these treatments and asking what's wrong or what would you like to see in the future and different things like that. And there are many diseases and I guess like inheritable diseases that get unnoticed by the scientific community or don't get as much attention as such a big disease like cancer. And I guess being able to talk to ordinary people and say, hey, why isn't there being more done for a smaller disease like childhood Alzheimer's is something that I really want to investigate in the future, because it's a disease that isn't getting as much attention, but it's got a lot of really sad outcomes for kids that are affected by this disease. And I think being able to talk to ordinary people or talk to the people around you and see what they want to see in the future. I mean, that's how we're going to progress as a society and make sure that everyone lives as good as a life as possible.
Wow, Rachel, I gotta say that's really quite inspiring, and I say that very honestly. That last little bit gave me some goosebumps. That's really, really lovely to hear. I'm gonna ask sort of one more question that is what I usually ask students as a way of wrapping this up. And what I usually ask students is, for sort of students, doing research is very hard. It's time consuming, it can be exhausting, daunting, so on and so forth. For students who might currently be a little bit afraid of jumping on this boat, what would you say to them? What has this entire experience brought to you, if anything? Or you can also say, don't do it. What, if anything, in this would you say to someone who's considering research?
I think that if you're considering it and you've got something you're super interested in, or even if you don't, but you've got a feeling that you really want to dive deep and investigate in something, I think research is good for anyone. I mean, coming into this program, I had no idea how to write a research paper. I didn't know how to make figures for a paper using BioRender, which is a very fun tool to use, by the way. I didn't know anything about citing sources or making in-text citations. And all of that is guided by CCIR and your mentor, and they're super supportive and you can always ask questions. So there's nothing to be afraid of, I guess, because I came in with only basic knowledge of science and I didn't know how to write a research paper, but I got to go home every day and look forward to basically writing a really long essay, but it wasn't that to me. It was being able to kind of learn more and investigate something I was really interested in. And it didn't feel like hard work because I got to learn and I got to investigate something I wanted to, and I got to challenge myself. And I think being able to explore new parts and like discover things that you didn't even know existed is good for you because you kind of get to experience the world outside of just school and tests and assignments and see the real life applications and impacts of what you're learning and how it will continue to impact the world and be able to help people with this knowledge.
That's as good of an answer as anyone could possibly give, Rachel. Thank you so much for sharing so much about your experience at CCIR as well as your project. It's really been wonderful to hear that you've had such a good experience and that it really was this sort of inspiring and edifying process for you. With that, I just want to say thank you so much, Rachel, for taking your time today. It was an absolute pleasure, and I wish you best of luck in all of your future social and scientific endeavors.
Thank you so much for having me.